Okay, let's take a look at multiplying binomials when they have radical components, radical terms. Keep in mind the old rule of when you multiply radicals, if you have, let's just make a little problem up right here. Your outside numbers, your coefficients, they multiply together. They multiply each other, so that's going to be 10. And then your radicands, the numbers underneath, they go together, but they never, ever, ever intermingle. So outsides go with outsides and insides go with insides. They don't cross over. So, and then from there, you have to break it down according to your rules. So that one would need to be processed. But just remember when you're multiplying, don't cross over. So you're going to use your basic, some people like to use FOIL. I'm not a fan of the FOIL idea because it does not work if you don't have binomials. I would rather you think through it with the concept of distributing, which will always work no matter how large your polynomials are. So let's just start with this term. You're going to take him and you're going to multiply him times everybody over here and that polynomial. So square root of 5 times the square root of 6. They're both underneath. So you're going to get the square root of 30. Go back, square root of 5 times negative, don't forget your sign, negative square root of 2. They're both underneath, so that would be square root of 10. All right, come back, grab the next guy. Make sure when you grab the next guy or the next term, get the sign with it. If you don't, everything's going to be off. So let's see here. The 3 is times this 1 out here. So you're going to get a plus 3, and then underneath will be the square root of 36. For right now, just write that so that you can keep processing. So that was that one. And then we're going to have positive times negative is negative. 3 times 1 is 3. Square root of 6 times square root of 2 is square root of 12. So you've got the multiplication step done. Now, you're not allowed to leave it that way. So because part of, as I call it, math etiquette, if you have a radical, you are supposed to reduce it or simplify it as much as possible before you leave it. So you have to think, are there any perfect squares that divide into 30? No, they're not. The only thing that goes into 30 is 3 and 10. That's not on your list. And neither is 5 or 6. So, and 1 and 30 doesn't help you. So square root of 30, it is. He's done. Think about 10. The only thing that goes into 10 is 1 and 10. That doesn't help. And 2 and 5. They're not on the list either. So he's stuck. Okay. Now you come over here and you're like, oh, 36. 36 is on the list itself. Square root of 36 is just 6. So replace this guy with just a regular old 6. Remember, when you take the square root, the radical goes away. You just get the number. So no more radical when you take the square root. But you haven't multiplied yet, so that's the reason I'm writing it like that. Okay, leave the little 3 outside. He's got to be patient. You can break 12 down. 12's not on your list, but one of the numbers on the list goes into 12. 4 times 3. So you always want the biggest number, biggest perfect square that divides into your radicand. Now, everything else just kind of needs to be brought down so that you can work with this. This is going to be square root of 30 minus the square root of 10. They are not like terms. This is like saying x minus y. You cannot put those guys together. You can multiply 3 times 6, but again, he's a constant. You can't put him with the other two terms. Now over here, let's see if we can do this expediently. The square root of 4 is 2. So 2 times the 3 that's already out here gives me 6. And this 3 is stuck underneath here. So hopefully you followed that. The square root of 4 was 2. And 2 times the 3, that's where the 6 is coming from. Now you can glance at it just to make sure none of these are like terms. That means that you are finished. This is your answer. Okay, let's do another, just to kind of give you a variation or some flavor to it. There's no coefficients here, so you should be able to rock and roll with it pretty good. The only thing I would warn you about is there's negatives in both. So be very careful with your signs. So let's see here, the square root of 42 And we're going to distribute over here. It's going to be negative square root of 12. Grab the negative with the square root of 8. So we're going to have negative square root 56. All right, and then we're going to have positive square root of 16. So you always just multiply. Just go ahead and get something down. Then go back and worry about breaking it down. Do one step at a time, otherwise it's going to be like you're overwhelmed. So go back and think about each one of these guys individually. Just focus on 42. Is there a perfect square that goes into 42? And I know 2 does, but 2 goes in there 21 times. 21 is divisible by 3 and 7. So there is not a perfect square that is a factor of 42. So it seems like a really big number to not be able to break down, but you really can't. So it's just the square root of 42. Well, here's that 12 again. Remember, that's 4 times 3. Now, if you wanted to, you could go ahead and take both of those on down. Now, 56, does 4 go into 56? Yes, it does. 14 times. Now, think about the 14. 14 is made up of 2 and 7, so there's nothing else hiding in there. So you can definitely use 4 times 14. So the square root of 4 ends up being 2. And, oops, I need to put my 14. And I realize that doing 2 lines down like this might be a little unorthodox, but it kind of depends on, do you want to just keep your mind working with each term all the way down? You know what I'm saying? Work with this all the way down, work with this one all the way down, this one all the way down. So you're not constantly swapping gears in your head. Oops. Let me put my 2 back. There we go. Now, come over here, square root of 16. You should know that. That's 4. So I'm going to put a 4 at the end. Now, check out all your terms. I have a constant, square root of 14. I don't have another one. Square root of 3. I don't have another one of those. Square root of 42. They're all different. I'm done. Okay. Slight variation. Hopefully you realize that whenever you have raised to the second power, there's 2 ways of doing this. There is a special rule, which is square the first. Won't write. Okay. Twice the product. And square the last. So that will work like a charm if you remember the rules, because this is supposed to give you a trinomial, and this gives you every term in that trinomial. If you have a hard time remembering that, then let this 2 here remind you that there are 2 of these binomials, and that you need to write both of them. So just copy it twice. If you'll copy it twice and then do exactly what you've been doing, you'll get your answer. But there are some little anomalies that happen because it is the same terms written twice. So square root of 5 times square root of 5. What we said in earlier videos was when you have the same term and you're doing square root, what happens here, the shortcut, that's the square root of 25. You're just going to get a regular 5, not the square root of 5. It's just going to be 5. Square root of 25 is 5. So it's like when you do square root of 5 times square root of 5, the radicals go away. All right, go to this one. Don't forget your negative. Negative, this 5's on the outside. These guys are on the inside. Square root of 15. All right, now come back. Grab that. Make sure you got your negative. Negative. And this is 5's on the outside. Square root of 3 times square root of 5. Hinky. Same thing. Did you notice that? And then I'm doing these. All right, 2 negatives now make a positive. Outsides go with outsides. It's 25. Insides go with insides. That's going to act just like our first one did. Square root of 3 times square root of 3 is just 3. Regular 3 now. So I've got 5, and then do you see this? You can't break down the square root of 15 because that's just 3 times 5. But you have 2 of them. So those are like terms, and you can put them together. So you have 5 here and 5 there. Don't change what's under the radical. That's just like saying I have 5 apples and 5 more apples makes 10 of them. So you're just telling me how many things you're counting. And now just do the math over here. 25 times 3, 75. Well, once again, you have like terms. So 75 and 5 is 80 minus 10 square root of 15. You can't put these together because he has a square root of 15 and this one does not. So you are finished. Okay? One more. This is very interesting, and this is something that you're going to use here in the next little thing that we're going to talk about. These are conjugates. Conjugates are special. They're very special, and you should see that whenever we get toward the ends of these. It is the exact same terms with opposite signs. And it really doesn't matter which one's plus or which one's minus, just as long as they're different. Something wonderful is going to happen. So let's get to multiplying. Square root of 8 times square root of 8, that's just 8. Square root of 8 times negative square root of 13, okay? In all honesty, I don't know what 8 times 13 is, so let's take this in. 104, okay, so 104. Then we're going to come back, we're going to grab this guy, multiply. He's positive. Check that out. Interesting, huh? Now, go here. We got positive times a negative is a negative. Square root of 13 times square root of 13. Remember, he's now free. Boom. Check it out, guys. You have a negative square root of 104 and a positive square root of 104. They cancel out. That is the beauty of conjugates. No more radicals. Please get that stuck in your mind, in your brain. You can do this. Conjugates are important because they eliminate radicals. When you finish and you complete your problem, you're going to get these, whatever your terms are that are left, it will be it's going to be a rational number. No more irrational, okay? No more square roots. It's beautiful, and we're going to have to use that here in just a minute. So, hope that helps.